So, guys, we are talking about Dijkstra's algorithm. So, we will see one of the example to understand it very clearly. So, this is the example, and we have to define or we have to write shortest path among this network. So, initially we assume that we start from the node number first, and we have to write the minimum distances from node number 1 to each of the node 2, 3, 4, and 5. So, initially we start from node number 1. So initially we visit node number first here. So from the node number first, the distance of node 1 will be 0 as it's the same node. Okay, so distance of node 2 from the node 1 will be a 4 since 1 and 2 are directly connected. Now distance of node number 3. Now 1 and 3 and are not directly connected, and there is no any intermediate part in between them. So distance will be dash. Okay. Now node 4. Now node 4 is directly connected to the node number 1. So distance between them will be 8. Okay. Now node number 5. So 1 and 5 are not directly connected, and there is no any intermediate path, or there is no any intermediate visited node to write the path between 1 and 5. So we will write distance between 1 and 5 will be dash. There is no distance between them. Now since we have visited node number first, so we have to check what is the minimum distance among the non-visited nodes. So minimum distance among the non-visited node will be 4. So we have to visit node number second now. So we will visit node number second. Okay. Now distance 1, this distance visited nodes distance will be the same. So there will be 0, here will be 4. Now we have to define the distance to the node 3 from the node 1. So we will get part like 1, 2 and 3. So distance between 1 and 3, and the intermediate node will be 2 here. So distance between 1 and 3 will be 7. Distance of 4. Now here are two paths to come to 4 from the node number 1. One will be 1, 2, 3, 4, and second will be directly from 1 to 4. Since in the path 1, 2, 3, 4, the distance will be 4 plus 3 plus 4 will be 11, and distance from 1 to 4 which is directly connected will be 8. So we have to take the minimum distance. So distance 8 will be 8 as it is, since this distance is more than the previously written distance. Okay. Now we have to write the distance for the node 5 from the node 1, since the 4 is not visited node. So we have to follow the 1, 2, 3, 4 and 5 path. So distance will be 4 plus 3 plus 4 plus 7 will be 18. Now we visited node number 2, so we have to choose minimum distance among the non-visited nodes. So non-visited nodes are 3, 4 and 5, and minimum distance from these nodes will be a 7, 1. So we will visit node number 3 here. So node number 3 we will visit, guys. 1, 2 and 3. So this distance be gonna same here, 0, 4, 7. Now distance of 4 when we visit node number 3 will be as it is, as distance will be 4, 7 and 4 will be 11, and distance from 1 to 4 directly 1 to 4 is 8. So it will be 8 as it is. So distance of 5 when we visit node number 3 will be same, 1, 2, 3, 4 and 5. As node 4 is not connected, so we are not gonna follow this path 1, 4 and 5. Okay, so distance will be 18 as it is. Now we have to find the minimum distance among these nodes. So minimum distance will be 8, and we have to now visit node number 4. So we will visit node number 4. 1, 2, 3 and 4. So these distances are gonna be the same here. So 0, 4, 7, 8. Now Distance of node 5 when we visit node number 4 will be 8 plus 7, that is 15, which is minimum than previously mentioned distance 18. So we have to write minimum distance from node 5 from the node 1 will be 8 plus 7, 18. We are not taken previously this because we haven't visited node number 4. But now we have visited node number 4. So distance will be 8 plus 7, 15. Now we will visit remaining node, that is 5, 1, 2, 3, 4 and 5. So these distances are gonna be same, 0, 4, 7, 8, 15. So this last row means this last row quantities or entities represent the minimum distances of each node from the root node, that is node number 1. So thank you guys for watching my video. Thank you.